Hello kids. So I hope you have revised HCF and have done the practice questions. And in today's class, we will start with LCM. LCM is least common multiple, right? And we have already learned LCM in our previous class in grade 5th. But now as a part of grade 6 syllabus, we are going to learn LCM by two different methods. The first one is the prime factorization method and the second one is the division method, and both the methods are very easy, kids. So let's start with the very first method, that is to find the LCM by prime factorization. So kids, what I'm doing here is I'm taking an example first and then we will go about it. I'm taking LCM of three numbers. So I'm taking the same question. This is 24, 36 and 40. What we have to do is we have to find the least common multiple of these numbers and we have to use the prime factorization. So what we have to do, we have to find their prime factors individually. So for 24, let's do it. We have 2 into 12, 2 into 6, 2 into 3, 3 into 1. These are the factors. So let me write these factors and I am writing them in the term of their powers. So we have 3 2's, that means 2 raised to the power 3. And we have only 1 3. So 3 raised to the power 1, which is 3 only, right? So whenever there is 1, writing 1 is not required in the power. Next is 36. So for 36, we have 2 18, 2 9, 3 3 and 3 1. So I can write here for 36 we have 2 raised to the power 2 and 3 raised to the power 2, right? And now coming to 40. For 40 we have 2 into 20, 2 into 10, 2 into 5, 5 into 1. So for 40 what I have is 3 times 2, so 2 raised to the power 3 and 1 time 5. Okay, so now what we have is we have all the factors, prime factors of the given numbers, and now we have to find the LCM. So kids, in the case of HCF, what we used to do, we always used to take the common factors the lowest with the lowest powers, right? But in the case of LCM, what we have to do is we have to pick the numbers with the highest power first. First of all, we will go for the common multiples, and for the common multiples we have to pick the highest power. So if I see here all the factors of the given numbers, we have two common in all the three numbers. 2 is a common factor in all the three numbers. And what I have to take? I have to take the highest power of the common factor. And the highest power of 2 is 3 here, right? Because in 24 it is 3, the power is 3. In 36 it is 2 raised to the power 2, and in 40 is 2 raised to the power 3. So the highest power is 2 raised to the power 3. For the common factor, we have to take the highest power in LCM. I have taken 2 raised to the power 3. Next common factor is 3. And what is the highest power of 3? It is 3 raised to the power 2. So I am taking 3 raised to the power 2. So these are the common factors. But in the case of LCM, we have to consider the non-common factors also. So the non-common factor is 5 here. I am taking 5 as is. Now what we have to do? We have to multiply them. 2 raised to the power will give us 8. 3 raised to the power will give us 9 and 5 as is. So this is 5 into 8 is 40, 40 into 9 is 360. This is 360. So LCM is 360. So I hope that you have understood, kids, but again let's go through it once more. We have to find the LCM of these three numbers. So we have done their prime factorization. And after prime factorization, we have written their factors in the term of their powers. For 24, it is 2 raised to the power 3 because 2 is coming 3 times, right? And 3 is coming 1 time, so I have written it as 3 only. This means 3 raised to the power 1 only. And for 36, we have 2 times and 3 2 times. So same has been written here. The next we have 40. For 40, we have 2 raised to the power 3 and 5. Okay, now when we have to find LCM, what we have to consider here is we have to, I'm writing here also, we have to consider the highest powers of the common factor of the common factors. Okay, so what are our common factors here? 2 and 3. Highest power of 2 is 3. I have taken that. Highest power of 3 is 2. I have taken that. And now the factors which are not common, they will be as is. They will be written as is. And then we will multiply all of them and we have got the LCM here. Right? So this is the first question, first example here. Now, let us go through the next example in the book only. So what we have is, we have to find the LCM of 112, 168 and 266. So what we are going to do, we have to find their prime factors. This is 2 into 5 is 10 and then 2 into 6 is 12, 256, 228, 2 into 14 will give us 28, 2 into 7 is 14 and 7. So these are the prime factors of 112. How many 2's are there? 1, 2, 3, 4. So we will write 2 raised to the power 4 multiplied by 7. See, the same thing has been written here. 2 raised to the power 4 multiplied by 7. These are the prime factors of 112. Similarly, we have find out the prime factors of 168 and they are 3 times 2, that is 2 raised to the power 3 multiply by 3 multiply by 7. So 2 raised to the power 3 multiply by 3 multiply by 7, right? Because 3 and 7 are coming one time only. And the last we have 266 and the factors are 2, 7 and 19 all at 1. All will have the power of 1 only. Now, what we have to do? We have to find the LCM. So for LCM, we will consider the common factors first. 2 is the common factor and then the highest power of the common factor, which we have 2 raised to the power 4. So we have 2 raised to the power 4 here. And then 7 has the same power. So the highest power is 1 only. So again we are taking 7 raised to the power 1. Now the factors which are not common, they are 3 and 19. So we have 3 and 19. We'll multiply all these numbers and this is our LCM, which is 6, 3, 8 and 4. 6,384 is the LCM here. Okay. So kids, this is very, very easy using prime factorization. But always remember one thing, that in the case of LCM, we have to consider the highest powers of common factor and the factors which are not common, we have to consider those also. We have to multiply those also to get the LCM, right? But in the case of HCF, we have to consider the lowest power of the common factors only, right? Which we have already learned. This is the first method, which is called as the prime factorization method. And now we have the division method also. So let's see what is written here. In this method, we arrange the given numbers in a line in any order, like this. They have written numbers in any order. We divide it by a number which divide exactly at least 2 of the given number. So we have to pick a number which at least divide 2 of the given numbers here. Okay, and carry forward the numbers which are not divisible. So numbers which are not getting divided by that number, they will be written as is. Now, the process is repeated till no 2 of the given numbers are divisible by a common number, and we have to repeat this process unless we'll get a number which is not dividing any of the given numbers. Now, the product of the divisors and the undivided number is the LCM. So the number which is remaining and all these divisors, when we will take their product, that is going to give us the LCM. Let's do this question, kids, and you will understand this better. So I'm writing here LCM by division method. This is very easy, kids. Let's do this method. So example 3. We have LCM, we have to find LCM of 12, 15, 20 and 27. We have to find their LCM. So what we are going to do, we have to write it, we can write them in any order. I'm writing this in the given order only. And then we have to divide it by a number which at least divides two of the given numbers. We can start with 3 because 3 is dividing 12 and 15 and 27, right? So let's start with 3. We could have started with 5 also because 5 is dividing 15 and 20. But it is always better to start with the number which is dividing maximum numbers. So here 3 is dividing 3 numbers. So let's start. This is 3. 3 into 4 is 12. 3 into 5 is 15. 20 will be as is because we know that 3 is not dividing 20 completely. So we will not touch 20. We will write it as is. And then 3 into 9 is 27. Okay. So 3 is done now. We cannot divide 4, 5 or 20 with 3. So we will not consider 3 now. So for the next, let us consider 4 because here 4 is dividing 4 and 20 both. So we have 4 into 1. 5 will be as is. 20 is 4 into 5 is 20. And then 9. It will be as is. Okay. So now next what we have? We can use 5. So we have 1, 1, 1 and 9 as is. So 9 is the remainder which is not getting divided. We can also do it like this. I can also do it like 9, 1, 1, 1, 1. This is also correct. Okay. So now what is the LCM? LCM is product of all these. That is 3 into 4 into 5 into 9. So this will give us 5 into 4 is 20, into 3 is 60, 60 into 9 is 54, 540. This is the answer. Okay, so this is LCM by division method. Again, let us go through this again. What we have is, we have to find the LCM of the 4 given numbers. We are writing them in one line, and then we will pick up a number to divide them, which at least divide 2 of the given numbers. So here we have taken 3, and the number which is not getting divided, we are writing that number as is. Okay, so what we have to do, we have to keep it on dividing till we get maximum ones here. And then you can have 9 as a remainder, which they have written like this, or otherwise you can also divide it by 9. Okay, and then the product of all these divisors will give us the LCM here. Okay, so this is the first part. This is the first example. Now we have another example also here. Let us do it here only. What we have is, find the LCM of 22, 54, 108, 135 and 198. So kids, if you see here, we have 1, 2, 3, 4. We have 4 even numbers. So it's better to start with 2 because we know that 2 is going to completely divide these numbers, right? So we have 2 into 11, then 227 will give us 54. 2 multiplied by 54 will give us 108. 135 is not getting divided by 2, so we are writing it as is. Okay, and then 2 into 99 is 198. This is done. Now if you see these numbers, we have 2 multiples of 11. One is 11 itself, second is 99. So we have considered 11 as the next number to divide. So we have 11 into 1, 27, 54 is as is, 135 is as is, then 11 into 9 is this. Okay, and next we know that 27, 54 and 9, they all are divisible by 9. So we have taken 9 as the next divisor. We have 9 into 1, 1 as is, then 9 into 3 is 27, 9 into 6 is 54, 9 into 15, this is also divisible by 9 is 135, and 9 into 1 is 9. And then we have 3, 6, 15, so we are taking 3 here. And we have 1, 1, 2 and 5. So kids, you can keep them as remainder, or otherwise you can also extend them and do it with 2 and 5 individually. Okay, but in both the cases the product will be same, the LCM will be same. So now to find out the LCM, what we are doing is product of all these and product of these remainders. Okay, so this is our LCM, right? So I hope that you have understood the concept of LCM from both the methods now. Okay, so we have more examples on this. Let's go through this question. Yeah, Find the smallest number which when diminished by 3 is divisible by 21, 28, 36 and 45. Okay. So what they are saying is we have to find a number. I'm writing here. Let us say, let's take, I'm writing the number as X. So kids, if we have to find out any number, we don't know it, we can take it as any alphabet. We can assume it as any alphabet and then we can derive its value mathematically. Okay, we can take any alphabet, but usually we take X, Y, Z and all. So I'm taking X here. What we are asked to do here is that we have to find the smallest number. This is the smallest number, and which when diminished by 3, that means which is when subtracted by 3, will give us a number. It will give us a number which is divisible by 21, 28, 36 and 45. So can I say that we need this smallest number which is when subtracted by 3 will give us the LCM, because it will give us the smallest number which is divisible by 21, 28, 36 and 45, right? We need something like this. So let us try to find the LCM of this number. Okay, so kids, if you see here, we have 21, we have 28, 36 and 45. We can start with 2, we can start with 3 also, and we can start with 7 also, like what they have done here. But let us start with 3 here. Okay, so we have 3 into 7 is 21, 28 is not divisible, as is 3 into 12 is 36, then 3 into 15 is this number 45. Next, I can take 7, 7 into 4, 12 as is, 15 as is. Next, I can take 4 because 4 and 12 both are multiplied by, both are divisible by this 4. Then 3 here and 15 here. Next, I can take 3, 1, 1, 1 and 5. And again, I am taking 5 here, 1, 1, 1 and 1. So what is the LCM? It is the product of all these numbers, which is 3 into 7 into 4 into 3 into 5. Right? So we have 3 into 7 is 21, 21 into 12 into 5. 15 into 12 into 5 is 60 into 21. This will give me 61260. This is my LCM. Okay. So what I can write here is that the number which I want, which is when subtracted with 3, is giving me the LCM, or that is the smallest number common to all these, their least common multiple. So that means X is what? 1260. This 3 will move to right hand side and will become plus. So the number which we wanted here is 1260 plus this number goes there is plus 3 is 1263. Right? This is what we wanted. Okay. This is done, kids. Next. In a shop, there are 3 clocks which chime at intervals 15, 20 and 30 minutes respectively. So there are 3 clocks which chime at the interval of 15, 20 and 30 minutes. They all chime together at 10 a.m. So that means that this 10 a.m. is the time when all the 3 clocks, they chime together. Now, at what time will they chime together again? So kids, this is very easy. What we have to do is, we know that all the 3 clocks will chime at their least common multiple. So what we will do, we will find out their least common multiple. Okay. And once we know the least common multiple, the number of minutes, we can add those minutes to 10 a.m. to get that the next time when all the 3 clocks are going to chime together. Okay, so let's see what they have done. We have 3 numbers 15, 20 and 30, and we have taken out their LCM. Using the division method, the LCM is 60 here. 60 as in we are talking about minutes. So this is 60 minutes. Okay. This is 60 minutes. Now these three clocks, they chime at 10 a.m. After 60 minutes, they will chime again. That is they are going to chime again at 11 a.m. now. Right? Because what we have done, 10 a.m. plus 60 minutes, that is 1 hour. It is giving us 11 a.m. And when after 11 a.m.? 12 noon. And then 1 p.m. and goes on. Right? You can add 60 minutes every time. Why? Because that is their common multiple. Right? This is done. So now kids, I hope that you have understood the LCM in a good way. We know that how we have to find the LCM using the prime factorization and division method both. Now let's go through the properties of HCF and LCM. So what they are saying is the HCF of a group of number is not greater than any of the given number. So that means, let's say example, I'm taking here any four numbers 67, 23, 116 and 148. Just an example. So the HCF of these numbers will not be greater, it will not be greater than any of these numbers. Oh, sorry, is not greater than any of the given numbers. This means it is always less than this number also. Okay. Next, the HCF of two primes is 1. This we know, this we have seen. Then the LCM of a group of number is not less than any of the given numbers. So what it is saying is, like HCF, we have done HCF. Wait, let me raise it here only. What it is saying is, for the case of LCM, for a group of numbers, LCM is not less than any of the given numbers. It is not less than any of the given numbers. It will be greater only. Okay. Next, the LCM of two coprime is always their product. We know that the two coprime numbers, they are not divisible. So their LCM will always be their multiple, their product. This we have also done in grade 5 kids. We had questions based on. So what we have here is the HCF of a group of number is always a factor of their LCM, right? So what they are saying is, I'll explain you using this example. We have 12, 16, 36 and 40. And let us try to find out their LCM first. Okay. So their LCM will be, I'll start with 2 here because all are even numbers. This is 2 into 6, 8, 18 and 20. After that, again I can take 2. This is 2 into 3, 4, 9 and 10. Right? Next, I can take 3, 1, 4 and 3, 10 as is, 4 as is. Next, I can take 2 here. We have 2, 3 and 5. So we have these 3 as remainders. I can go on and solve this like this, or I can keep them as remainder only. We have 3 into 5 here, which are remainders. So what is the LCM? It is the product of these. 1, 2, 3, 4. So we have 2 raised to the power 4 and 1, 3, 2, 3 raised to the power 2 and 5. So if we multiply, this is 16, this is 9, this is 5. This is 15 into 6, right? 16 and this is 3 into 3 is 9, this is 5. So if we take out their product is 720, which is nothing but the LCM, right? So this is the LCM. And now for these numbers, if we are going to for these numbers 12, 16, 36 and 40, if I will take out their HCF, that is the highest common factor, which is going to divide all these numbers. So kids, if we see, it is 4 here. Okay, the highest common factor, we can clearly see that it is all are the multiples of 4, right? And the highest common factor will be 4 here. So now What this property is telling us is HCF of a group of numbers, which is 4 in our case, is always a factor of their LCM. So we can see here that 4 is a factor of 720. We know this, right? So HCF 4 is a factor of LCM, which is 720. So this is the property told to us. Next property is if A and B are two given numbers, so they are saying we have two numbers A and B such that A is a factor of B. A is a factor of B. Then HCF will be A and LCM will be B. This is actually the same property which we have done above. We have learned that HCF is a factor of LCM. Same thing has been said here, that if A is a factor of B, then that A will be HCF and that B will be LCM. And they have taken example of, we know that 8 is a factor of 32. We know this, that 8 is a factor of 32. And clearly the HCF of 8 and 32 is 8. Let us find out the HCF of 32 and 8 here only. We have 8 into 4 is 32, complete multiple, so HCF is 8, right? So clearly HCF of 8 and 32 is 8, we have seen. And now what is the LCM of 8 and 32? Let us see the LCM of 8 and 32 kids, right? This is straight 8 and 4, 4 and 1. So LCM is what? LCM is 4 into 8, which is 32. So we have the same thing. We took two numbers as 8 and 32 and it is saying that A is a factor of B. We know that 8 is a factor of 32 and we have find out that the HCF of these two numbers 8 and 32 is 8 and the LCM of these two numbers is the number itself, which is 32. So this is true. That means in this case A is 8, which is the HCF, and B is 32, which is the LCM. So the two numbers were 8 and 32. 8 is a factor of 32, 8 is HCF and 32 is LCM, right? Next property we have already done in grade 5 and it says is that if two numbers are given, then the product of two numbers is equal to product of their LCM and HCF. Okay, so example, what they are saying is, if example we have two numbers A and B, so the product of the two numbers will be equal to product of their HCF and product of and LCM. Okay, so that means out of these four, if we know the value of any three, we can always find out the value of the fourth one. If we know A, B and HCF, we can find out LCM. Similarly, if we know A, B and LCM, we can find out the value of HCF. Same, if we know both of these and one of these, we can always find out the value of the another number. And we have already done the questions based on this in grade 5. So this is the formula, that if we know if we have to find out the LCM and if we know both A and B and the HCF, we can always find out the LCM, and same for HCF, right? Now what we have to do here is find the HCF and LCM of 1152 and 1164. So in this example, they are asking, we are given two numbers, this, and we have to find their HCF and LCM. So first, what we are doing here is, we are using the division method to find out the HCF. So we are dividing 1664 with 1152 and we have got 128 as the HCF using the division method. So now we know one number, we know the another number, which is B here, and we also know the HCF. We have just find out 128 and we can always find out the value of LCM. How? 1152 multiply by 1664. A is this number, B is this number, HCF is this number. We can solve this and we can find out the value of LCM, right? So we should always remember this too, that the product of the two number is equal to product of their HCF and LCM also, right? So this is the end of this topic LCM, and next we are going to pick the exercise based on the LCM. Okay, so I'll pick that in the next class now.